Unit 18, Part 4. So we've just gone through the proof for the argument which motivated this section of the logic, that some people don't like any dogs, all puppies are dogs, so some people don't like any puppies. We went through that proof. Just want to make a critical remark about what Klenk says when she runs through this proof. So bottom of 342 onto 343. At a point on 343, she says, the first full sentence, top of 343, she says, the instance will obviously be P, A, and for all Y, if Y is a puppy, then A does not like Y. Since, that word I want to critique, since we already have the PA, right? It's this sentence right at the top here. This since, right here, this since is out of order. That suggests that it's because we already had PA as a conjunct, that's why. That's the instance. No, that's not right. The instance is that formula, PA and blah, 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 because of the form of the existential statement that we have as the conclusion, right? That's what determines the nature of the instance, right? We already have PA in the deduction, so we need to get the second conjunct, but that since is out of order, right? It's not why that's the form of, that's not why the instance is that the particular formula. Okay, so let's work through the next one. This is the example, this is B, this is another good one for seeing how the matching works. Really, a lot of these proofs come down to matching variables with predicate letters at the instantiation stage, right? Especially when you're doing universal instantiations and you have choice. The difference between getting the proof done and failing to get the proof done is resolving the choice of what letter you replace the variables with, resolving that choice in the right way. So you'll see more of how that works in practice in this proof, which Klenk works through, 344 to 345. She says after her proof on 345, one of the trickiest parts of constructing proofs in relational logic is to know what letters to use in your instantiations, right? Exactly right. Although she doesn't really spend that much time elaborating on how you go about resolving it. But you'll see it as I do it. So this is the proof. Once again, let's start by taking stock of the form of the statements. One is indeed in quantifier form, right? I should say this. In relational predicate logic, taking stock of the form of the statements should go a little further than taking stock of the form or noticing the form of the statements in just monadic predicate logic. It should go a little further in that you should take note of the form, specifically determine whether it's in quantifier form or something else. That's the most important distinction. Remember back to Unit 14. That was the whole lesson. But you should also think another step ahead, right? What will the result, if it's in quantifier form, what will the result be? Right? After I've done my instantiation, will that be in quantifier form, or is that a conditional, or what, right? So here, taking stock of the form of the form of premise 1 is, yes, it is in quantifier form, it is a universal statement, so I'm going to UI on it, I'm going to instantiate it at some stage, maybe not right away. Why? Because the whole thing is often the whole proof comes down to universally instantiating to the right letter. So you have to do a bit of thought to figure out what letter you want to instantiate to, right? So continuing to think through the form of 1, taking the second step, after I instantiate on 1, I'll have a conditional, right? Hook P something, maybe PA or PB, depending on whether I replace X with A or B, or C or D or E or F, but in practice we only have recourse to use 2 letters usually, though I think the next example she does has a few more. Okay, so grasping the form of 1, it is a universal statement I'm going to universally instantiate. The result of that universal instantiation is going to be a conditional, the consequent of which is a quantifier statement, right? The antecedent of which is going to be a singular statement, probably either PA or PB, depending on what I instantiate to. Take stock of the form of the second premise. It's a universal statement, right? The scope of that universal quantifier goes all the way to the end, right? You actually don't have a legal formula, right? Like covering up, when you get to a legal formula, that's what you're quantifying over. That's the scope of your quantifier. For all y, that's not a legal formula by itself. And then what y binds, it's the whole thing. That x binds the whole thing, right? So it's a universal statement. And the result of universally instantiating from one, it's a universal statement, so I'm going to universally instantiate from it. The result of universal instantiating from premise 2, will be another universal statement, right? It'll be for all y, f, y, a or b, hook, l, y, a or b, whatever I instantiate to, right? Okay, and most important, most crucially, remain conclusion driven, most important to take stock of the form of your conclusion. It's a universal statement, right? And now I'm asking so it's a universal statement, so I'm going to get this by probably universal generalization. Oh no, that's the really, really hard rule. That's the one where I have to set up a flagging subproof before I do universal instantiations, right? So that's the first thing I'm going to do. But I'm also thinking, right, in terms of the 2 steps ahead type idea now, I'm asking, what will the form of the instance be? What will the particular instance be? What will its form be from which I'll be universally generalizing? Okay, since this is a universal statement, right, and I want to set up for, I want to follow the strategy rule, hard rule before easy rule. Second of 2 instantiations of that is set up for universal generalization before you do universal instantiation. So I want to set up a flagging subproof first of all. That's the first thing after the premises and the conclusion are written down. It's the first thing I want to put on the page, right? So step 3 is flag, I'll flag A. Hasn't appeared yet. Flagging step for UG. Okay. What else do we do when we set up for UG? How is it like conditional proof again? That's right, we put the instance down here. Reverse of instantiating. I'm just instantiating in reverse, basically. So what am I doing? I'm deleting the quantifier. I'm replacing the variable with what? With A. I've set up an A flag subproof. The letter I've picked for the subproof determines what the instance will be. So what do? I replace all the instance, I delete the quantifier, I replace 2 things. I replace all the x's with a's, and I leave everything else in place. I leave any y's in place. Any quantifiers involving y, and any y variables. I leave them as is. And be very careful to get the right form of the instance, right? By deleting the quantifier, the instance I get should be in truth functional form, specifically here, conditional, right? So x goes to A, this becomes PA, hook, right? Quantifier stays, that's an existential y, so it's a conditional, the consequent is existential y L, y stays in place, it's L, y, x, y stays in place, the x becomes an A, okay? And what I'm thinking is I'm going to be G'ing, from what number I don't know, but I'll replacing A with X. All right, that's what I'm going to do. Okay, so now I've got 2 universals, and I've thought the second step ahead a little bit. And what am I going for? Well, now I'm going for this instance. It's a conditional, okay? So I'm going to set up for conditional proof. Setting up for conditional proof, by the way, don't be confused. Right, you assume the antecedent, put the consequent down the bottom. Assumption for CP making the assumption is not a flag step or anything like that. Don't confuse flagging steps with setting up assumption. It's fine that A is here, even though A has appeared. That's fine. This is not a flagging step. But I put the assumption up here, step 4, and of course, like EG, how was E? We asked how was UG? How is UG like CP? In conditional proof, you always put the consequent here so that you know where you're going. Oh, and that is very crucial here, because that's going to be the key to the matching. Very crucial here, right? L, Y, A, right? Not using any variables here, I'm just doing a CP. This is a conditional, so if I assume the antecedent just as is, and I derive the consequent just as is, no variable changing, right? Then I'm entitled to infer that if PA, then there is a Y that L's A. Okay? And that's crucial, right? That's crucial that in this setting up to CP here, you have this specific formula, because this is going to be key to your matching, right? Basically, you've got notice that you've got, another thing you should notice about the form when you're taking stock. You've got 2 relational predicates, two-place predicates, right? One of them is L, and one of them is F, right? And they're bound by variables amongst the premises, and really what you're paying attention to, what you're trying to get knowledge of, is what those X, they're both YX, they're all YX, okay, what those Y and X's replace to. Does A go here or here? Does B go here or here? Right, that's what you're looking for, and you sort of have an answer, right? Just working backwards here. That had to be the instance, right? That is the conclusion of the conditional proof. It's L, Y. So probably, right, I'm in mind here of that second place of the L predicate is going to get replaced by A, right? This is matching. This is in practice how you work out what she says after she works through this proof on 345. One of the trickiest parts of constructing proofs in relational logic is to know what letter to use in your instantiations.